Hello, gentle readers. January 17, 2025. Today, from a study with Ross Finlayson, is Reading Foundations, kind of a postscript, in a sense, to Logos 2000, after Moment in Motion and the Descriptive Differential Dynamics. It is part of the philosophical foreground to help express that there is a foundations, and we're reading it, and so then the idea of how to one might say interpret that in an intersubjective, interrelatable language of a sort is part of the course of the study and research of foundations and infoundations. So today, it will be just kind of finishing off the rest of this box of books, looking through it, leafing through its contents, toward the idea then that it will somehow contribute to the narrative without merely being repetitive and hammering away at the points as are given here, yet also as somehow introducing something novel, something new. In any kind of essay, it's always to be an exercise that there is at least some revealed aspect, or as part of the knackbaut and the entbergung of these things, the turning things over of the knackbaut, and how they hide and show themselves, or as what's revealed, the dialetheic, as after the aletheic, the discovery of things, aletheia, the term from the great etymological origins of our tradition of reason, about reason. That with that not saying very much at all, let's see if something can be found to figure out to kind of associate it. So the top of this stack is this quarks, leptons, and a popularization of sorts of some time ago. And what it is about, Jonathan Allday's Quarks, Leptons, and the Big Bang by IOP Press, second edition, say, has a bookmark in it of it, and another bookmark from the bookstore where I bought this, a great bookstore. I was reminded of today, thinking that for years and years I'd make a regular lunch break walk through downtown and go to this bookstore and see what it had arrived at, and there was almost always something new, and so that thusly day by day I carried the books and this. For $8, I picked up this from the Institute of Physics Publishing, which is, I never heard of that before otherwise, and it's not saying much. Bristol and Philadelphia, so out of the United Kingdom. The King's School, Canterbury. Jonathan Allday's second edition of Quarks, Leptons, and the Big Bang. The here will be related to stuff like Earman and Wald, or Earman Stachel and Corcoran. That being kind of from the East Coast, out of like Temple and University or Philadelphia, and these schools where Earman was he studies the Big Bang, and here we read like a book about cosmic censorship and the naked singularity and issues with singularities and how it gets involved geometrically with the how one might say multiplicity theory, that any singularity is just a branch in a multiplicity theory. That then Stachel is a writer in the philosophy of physics, and then Corcoran as another writer and philosopher has that the axiomless natural deduction is at least part of this. So they're each addressing kind of Simplicio, Salviati, and Sangretti, Galileo's interlocutors, or like Imre Lakatos's alpha, beta, gamma, and teacher, or something like that. These speakers, each having their own kinds of perspectives, that then, when talking about the singularity in the Big Bang theory, here is what it's to be talking about: quarks, leptons, and the Big Bang. That this is just basically, instead, is kind of an end account The latest things I was told today were that there's quark theory that was made for Higgs theory, and then there's the Big Bang and inflationary cosmology, and with one of those being in a super collider and the other one being the Sky Survey, that's all our biggest data, and so then leptons are just like the supposedly electrons or what, and about quantum electrodynamics and quantum chromodynamics. And then also trying to relate that to the other side of the telescope, or the Big Bang and after inflationary cosmology. So a few things haven't gone on with that. Is that, first of all, besides the quark physics, there's the hadron and the hadron physics. There's the muons, but even for the atomic and nuclear, there's the nucleons instead of the hadrons. Is like another way to look at the theory. So from reading Sachs. SACH, Sachs, and about the nuclear models of the nucleonic, and about the periodic table of the elements, and then also the isotopes and stuff like that, has that Higgs theory doesn't know anything about nuclear theory at all, meaning as about the nuclear forces. And so instead, it's just all about like the electrical forces is supposed to be as after the mechanical reduction, the electrical reduction, making a supersymmetry, supposedly this Higgs boson. And then as whether it's supposed to have discovered, and that defines what makes we can derive what is mass, the material of the material points and its conserved quantity, the amount of matter and material point, the mass of the things. Has that there's several things in science and the data have that while these are according to their energies and configurations of experiment of a sort and a type, are at the same time falsified, meaning that other data of other configuration energy experiments have the Higgs theory does not suffice. And if there's one takeaway from did they finally discover the Higgs boson? It's like, yeah. It's like, well, great. So it's the particle. It's like, well, no, it's a doublet. It's not in the standard model of physics anymore that way. It is not the standard model anymore this way. Considering that something like, what is it? Like when we talk about the standard development of real analysis and the complete ordered field, it's like, well, after you get to like 3 different kinds of continuous domains, there's like standard infinitesimals and standard signals besides the standard field. They're each kind of standard in their own way. And so for Higgs, there's Higgs, and then there's Higgsinos and little Higgs and other kinds of accounts of what makes for supersymmetry, again, not dead, again, and these kinds of things. So that then taking this sort of assortment of a grab bag of collection of ideas of quarks, leptons, and the Big Bang, is kind of a bit derivative of the time. It's some of its influences, and it's a contemporary account, but I don't think it would be said to be kind of a unified account, and that being a unified account has to be its own really sort of thing. It's kind of like the L principle of relativity theory is light speed is a constant, and then there's also another sort of L principle like the Lagrangian. As for the Lagrangian and Lorentzian, here the E Einstein energy and F forces and fields, the potentials, the potentialistic theory about an account of energy is conserved, since momentum can't be said to be conserved in the kinematic. It's not. And what that means for all sorts of accounts of particle physics, otherwise vis-a-vis energy, and then people try and say, well, it's easier for my derivation to just say momentum is conserved because then I can just forget anything else and I'm done. It's like, well, yes and no, you know. So this, for the E energy and the F Lorentzians and these forces and fields, any one of ways of which can make for invariant theory implementations of relativity theory. That this, like this Higgs field and like little Higgs, which is like, is the atom's graviton incredibly massy, or is it just exactly the same as the atomic mass? Or is it neutrinos? Any one of which kind of has an account for supersymmetry, not, breaking conformal geometry and invariant theory together, that these are the kinds of things. It's like, well, yeah, it's a sort of a wider account to be a unified sort of thing. It's got to be universal. And so then otherwise these sort of pluralistic accounts, or here it's just like a very shallow kind of surface appellation of like, well, these are the latest, greatest extensions, so this is the monument in the mountain. And it's like, well, there are others. And in fact, they're around each other. So yes and no. So let's see here, kind of what the approach is. So it talks about hadrons, hadron reactions, particle decays, the evidence for quarks, these being just the titles of the chapters. Experimental techniques. Interlude 1, CERN, the Center European for Research Nuclear. I believe that's what CERN, CERN, stands for. Comme français. Exchange forces. So forces and the force carriers is the idea is like, well, what's the force carrier that's like this graviton that's supposed to be the atom according to all these things that can add up? And it's like, you mean is it the Higgs boson or W or Z and this and that? And it's like, well, or is it neutrinos, the flux the other way of any of this kind of matters of motion? Or is it just the atom itself? If it can or can't be, how can that be? And it's just like its own virtual supersymmetric antiparticle, virtual partner. These are the things. So the force carriers and exchange forces get into models of events and parallel transport, the usual idea, and teleparallelism, another great concept, explaining why there's conformal geometry and a norm everywhere, for a metric being everywhere and a norm being everywhere. That these are the kinds of ideas. Interlude 2, anti-hydrogen. So this is besides like the virtual partner particles and the antiparticles, then like the antiparticles and these kinds of things. It talks about Big Bang and the evidence since Lemaitre and the redshift measurements. And today there's these days redshift bias and redshift distortion helping try to explain why dark energy is falsified. Otherwise, these theories that the evidence for the Big Bang and steady state each have their own ways to fit it to the data, and particularly that the ideas of since Finley Freundlich of tired light, and then for like Zwicky and that, but for Finley Freundlich or Erwin Freundlich, since the time of Eddington and Lemaitre and this and about physics account of redshift apparently as describing an inflationary cosmology. And as after what would have been an expanding universe, or vice versa, for the Big Bang cosmology, that it's kind of as similar as account to the supersymmetry. It's like painting oneself into the corner, the farthest distant corner, and it's like we've achieved this perfect progressive painting, and it's like you're stuck there, And so it's kind of similarly with this account of the Big Bang, which also has a very classical explanation. So it has very great strength, and it's very good to already know that as part of how that's a classical account of these things. That then looking at them together, though, and then when all this other stuff they can't agree to 120 degrees of decimal magnitude, the quantum mechanics and general relativity, is that they don't. And so then trying to make for a theory where gravity's in the middle again, it's like, well, the graviton's got to be looked at like three different ways according to these three different counts of supersymmetry, according to these tetrads of quantities or fields or forces, the tetrads of elements of these accounts for our three dimensions of space and array of time. So anyways, this book is discovering things. And then it talks about dark matter, the baryonic matter in the universe, the evidence for dark matter. What is the dark matter? Is given as a question. It's given as an exercise in the book. The answer is this: well, it's luminous matter, since as a rotating disk, it's free in its own frame, and so it's already accounted for. But you have to change mechanics so that it's more about space contraction, linear space contraction, rotational, and giving an account of the reasoning for the mental model, why it's more than the classical model. This was in the moment in motion, the world's turned bit. And for Aristotle, that there is no unmoved mover, but circular movement is eternal, and then unstoppable and immovable and that kind of stuff. Back down from that, making for an account of mechanics wise, like what is dark matter? And it's like dark matter is having reached the limits of this classical account, and then further in accordance with that, with the matters of mechanics, that it's an artifact of the physical model for its mathematical model. That's what it is. It says inflation, a cure for all ills, and then this is the inflationary cosmology and stuff like that, and that's been roundly paint canned as Guth's Mexican hat dance, and by that what it means is the sombrero has like a hump. It's like, well, it has a local minimum and then a local global minimum, but it kind of somehow stays in this local minimum for this inflationary cosmology because it has to point somewhere. When really it just ends up that's just adding fuzz to make fudge of the data to that these sort of tail coding wallpaperists of the physicist variety have so paint canned themselves and painting themselves so delicately into the corner of their classical quadratic partial account. Postlude, philosophical thoughts on page 374. So let's see what are the philosophical thoughts. Oftentimes, you or if you study it a bit, you'll find physicists say, well, like, philosophers don't have a say. And philosophers be like, well, of course, what is to say? All these kinds of things about it. But definitely, a philosopher of physics is a strong and strange sort of beast, and sort of a unicorn in a sense. But physics is, in that sense, a bit above otherwise just the simple model of computing, because that's finite, and furthermore, it's partial, and so it's incomplete at best. And he quotes Weinberg. It says, the more the universe seems comprehensible, the more it seems pointless. And it's like, well, you could read that kind of positively and affirmatively and say, it's like, well, that speaks to axiomist natural deduction. And then Weinberg was really pretty great because he's pretty expansive and ambitious and grandiose. But in the end, he said something audacious, and I was like, oh, no, I can't agree with you anymore. And he says, and then he quotes Dyson as saying, any universe that contains mind cannot be regarded as pointless. It's like, well, yes and no. I mean, what's pointless to me is matters of meaning, and purpose or teleology. And so these are accounts just like in the surrounds of all this stuff to do with logicist positivism, which is usually perceived to be kind of the weaker sort of logicist positivism. It's like, it's just a theory. When you hear something like that, it's like, that means it doesn't have any truth really associated with it. And then it's like, well, Tarski truth says you can say it's so because then it's just according to model theory, and it's axiomatic. And these sorts of accounts have here, there's pretty much already a wider surrounds of a wider, fuller dialectic to be explored, to be developed, to be established by any thinker themselves. And then as whether pointless also reflects besides on meaning and purpose to matters of the infinitesimal or the classical itself. So you could also read it saying they just destroy their own arguments this way. And so we'll leave it outside of that, though, because Weinberg has a lot going on with regards to what made for hadron physics. And Dyson has got some things going on, but I just kind of see him as part of like the operations research, management science crowd. And that it's too many of the speculative what ifs that have never been seen to arrive. Bizarre or absurd models, kind of like Hawking's accounts sometimes, half of them, or these kinds of things, or Penrose's fantasy sometimes, and the silly bits, but that's as well as a philosophical account. It's like saying they either make a philosophical account or they don't, and then it is pointless. And if they do, then it's not. And if it's not, then there is an account. So that's the usual kind of thing. Allday says, one thing is clear. Frequently when scientists dabble in philosophy, they get themselves into trouble. I am probably about to do the same. Physics is a very beguiling subject. As you work at it or study the works of others, it's very difficult not to get caught up in the incitement of the ideas and the conviction that this must be right. Well, here we can speak to the invincible ignorance of the inductive inference, and why there's a wider account. And Aristotle gives there's both prior and posterior. And so many Aristotelians take half of that and say they're done, which is false. And so then the idea of the inductive ignorance, the invincible ignorance, as with restriction and comprehension, has a usual account of the widest and wider expansion of comprehension is free. And then as to be conscientious and fair, it's unrestricted. And then restrictions are just establishing classical milieus and these kinds of things. So I can understand why this philosopher, I mean, he's thinking, he's got to be philosophizing somehow, has that this is why paradoxes are perceived. Has then they just got to be resolved, and that so much of the ideas of just saying that they're ignored is like the old idea of the ostrich, who when it observes danger, apocryphally the ostrich will just sink his head into the sands so he can't see the danger, but he doesn't much get anywhere that way, you know. Ideas have a power in science just as much as in politics. In science, however, the most powerful ideas also tend to be the most beautiful. Unfortunately, the same cannot always be said in politics. I cannot describe what a beautiful idea is. If you have read this book and been struck by the elegant simplicity and rightness of something, then you already know. All science aims to describe the universe in which we live. It produces a map of reality. However, when we study an ordnance survey map, it is not often that we're looking at a picture that seems equally as beautiful as the scenery that we are trying to navigate through. In science, the situation is not the same. In our case, the scenery, the true laws of the universe, if you like, cannot be clearly seen. They can't be not seen. Is more the idea. I mean, that's. He says it's very foggy out there, and that gets into the swamps. It's sometimes called these ideas of the morass. So, like for the inductive impasse, then there's like, well, how can we piece together these inductive accounts which are not relevant to each other, but as part of the picture that we give as part of the descriptive model overall, have to relate. And so the morass or the impasse or the swamps or here the fog is part of this account of the description of the unknown, kind of like the shadow of these things. Although shadow is its own notion of the potentials. So shadow and light have an interplay in that sense. At any moment, the map is incomplete and contains parts that do not seem to be quite right. But if it is a really pretty map, then it's very easy to forget this and concentrate on studying the map rather than the world. That's arbitrary. We can lean on Kant a little bit about the aesthetics of things, or Goethe or something like that. All our knowledge about the physics of vibrations will not explain why certain pieces of music have such a devastating emotional effect. So for the mental and the emotional and the moral and the ethical, these can relate to states of maturity. And so the idea of the notions of maturity is as of adulthood and also independence, and also in a sort of holistic account of towards completion and comprehension. So then trying to say here, for example, that there's emotional effects like of music or of other sorts of accounts, that would be often considered to be part of the catharsis of things. And so the catharsis of things has the mental and the emotional and the moral and the ethical get involved. The solidity, the crystalline aspects of their thing. And so when something like that becomes fragmented, or is like a colloidal suspension, results as of the liquefaction of these things. It was what was solid, and then it results as for the catharsis and the expression and the emission of these things. Has that a catharsis is usually seen as a positive sort of development, as like a gestalt. And then that the emotional impact is as part of the course of the development, and hopefully one that leads to the maturity vis-a-vis the pathology. And so that's not an unusual aspect of models of perception and cognition. The map we are currently looking at does not cover that aspect. The mistake is to forget this. So this map that Allday refers to could also be including, for example, transactional settings or an economical setting, where an account of economics is usually given for things like supply and demand, in microeconomics and macroeconomics. And then there's an account of an economist like Samuelson. And so Samuelson provides something called a utility function. And so this way is like every single thing has value. It's kind of like in physics, everything there's an event and it's value. So what's conserved in Samuelson's economics is value. Vis-a-vis like it conserved in physics is energy in the IntelliSheet. So value in the economy, say. But it includes the aesthetics, and it includes the birds and the bees and the humble ecology. So we have our economy and our ecology, and both of those are so related. And so then whether the map includes that is that yes, it does. Yes, it does in this sort of philosophy. The author, having acknowledged this, automatically equips it. Then whether or not everybody else has that on their map is a matter of the interrelatable and the intersubjective and this kind of stuff. Given this, what do we make of the apparent observation that some of the maps we have come up with, often the prettiest, seem to work so well? Einstein was very fond of it, saying that the most incomprehensible fact about the universe was the fact that it was comprehensible. The very fact that we can make a map is quite intriguing. Why would it not? Why would it not? Perhaps the explanation is not important. Well, the data has to match for all things. And so the explanation cannot include is just like censor that or ignore that because it doesn't fit on our map. It's not on our legend. It's like that's not the way of things. And he describes the great wonderful feeling of being able to compute and calculate things and see them hold. And then while that's so, there's a greater one also, because otherwise his wonderful feeling is going to be kind of stymied when he's confronting like this emotional development and these kinds of things. What is the general person in the street to make of all this? Some veer into scientism, the conviction that science can explain everything, and it can, because it doesn't say anything at all. It just says the scientific methodology. The attaching to the theories is a second kind of thing. And so scientism, then logicist positivism, here there's an account of why that's got to be stronger than what's usually given, because the way it's given is unvalidated, unjustified. Doesn't really fog. The point that I'm trying to make is that philosophy is a different activity to science. I will aver that he's either making a science about his philosophy or a science about his philosophy or a philosophy about his science of his philosophy about his science. Either way, what he says is either incomplete or inconsistent. Because otherwise, there's a philosophy of science, and it's for a science of philosophy. I was struck recently while explaining the Big Bang to a class of general studies students when one of them butted in to say that it must be impossible to understand everything about the Big Bang and still believe in God. That's given to the supreme and the omni and the super us, the supernatural, super and it's natural, and it's perfect. So that just doesn't seem very convincing a reason to say anything else. I tried to explain that many people see the elegant simplicity and power of the ideas of being evidence of existence as a rational mind behind the workings of the universe, but was not very convincing. That's anthropomorphism, so it's not very convincing. Some are predisposed to believe and see the map in those terms. Others are inclined not to believe, and that view colors their map as well. My philosophical thoughts on the matter run on two lines. Firstly, that the real trick is to stop looking at the map and to hold it up to the world instead. The second is the form of a question they keep coming back to. Where do the laws of physics come from? And he's got a list of all the people who ever won Nobel Prizes for physics. Discovery of the positron, 1936. Discovery of cosmic rays, 1936. The invention of the cyclotron. Creation of quantum mechanics, given to Heisenberg. Well, let's see here. Dirac. Discovery of new productive forms of atomic theory, quantum mechanics. Let's see. Davison and Thomson. Electron diffraction by crystals. See, that's a particular thing outside electromagnetic radiation usually, and the diffraction is optical when it results. So I have to look at Davison and Thomson a little bit and see about their methods, their energy and configuration of experiment, because that is otherwise not so regularly so. Fermi. Discovery of nuclear reactions brought about by slow neutrons, fission. So that's entirely separate from the usual account of the standard model of the hadron physics. Stern discovered the magnetic moment of the proton. Isidore Isaac Rabi, resonance recording of magnetic properties of nuclei. See, resonance recording, that's a great sort of account thing. So in 1944, there's resonance theory, above wave theory. It's wave particle duality, then there's resonance wave dichotomy. Pauli wasn't until 1945. Discovery of the exclusion principle. Bridgman, invention of apparatus to produce extremely high pressures. Discoveries made of that. So that gets into Fritz London and the superfluid and superconductivity and those aspects of the extremes of the regimes of the energy and configuration of experiment. Appleton's investigation of the physics of the upper atmosphere. So here was talked about in the planetary electrodynamics. There's like the magnetopause and the idea of that being kind of a sheath about the Earth and what that means for models of atmosphere, and then also as well as the contents of it, the electrical magnetic fields about the Earth. But that book that was examined here at the time was very, very much state of the art. 48, Blackett. Development of Wilson cloud chamber and discoveries made with it. So there's a whole experimental setting between like Millikan drop experiments and then cyclotrons that's like the cloud chambers and stuff like that, because different sorts of potentials can be induced across it, and so it's different stuff. Prediction of mesons by Yukawa. And so, yeah, mesons and as for the pi meson, but then for muons is those get related together. So here's the books about leptons, and it's like, what do leptons say about mesons? And it's like, they don't say anything, but they're different things. Part of these different tetrads of quantities. Powell and 50. Photographic method for recording particle tracks and discoveries made with it. Some more cloud chamber stuff. Cockcroft and Walton, transforming atomic nuclei with artificially accelerated atomic particles. Bloch and Purcell, development of new methods for nuclear magnetic precision measurements and discoveries made with this technique. So it kind of looks like half these nuclear prizes are like, one is like make a classical account of a simple thing. Another is like its resonance and make the structural accounts of the higher order. They disagree, see, is kind of the idea. But somehow they do agree. And all the data confirms it. Invention of the phase contrast microscope. Born in both in 54. The coincidence method and discoveries made with it. Yeah, well, that's incomplete. Lamb and Kush. And getting into, so Lamb was about like things like Lyman spectra, Balmer series, and all this spectra and spectroscopy, and then greater accounts of like for light, there's different accounts of incandescence and phosphorescence and fluorescence and the second spectra, and then like Newton's primaries after the usual account of the spectrum, red, orange, yellow, green, blue, indigo, violet, the one that's like primary colors vis-a-vis the one that's like second rainbow and this kind of thing. There are multiple accounts of spectroscopy to get involved. That it is mathematical to be first, besides that then it's also very evident via very simple experimental setups using light and optics. It says Shockley is discovery of the transistor, or the, NPN or PNP junctions, and the notion that there's a gate-controlled voltage, and as the capacitance and the effect. So there can be in silicon or solid state, the physics vis-a-vis what was before accorded by like a triode, the thyrotron or something like that. Cherenkov, Frank, and Tam, discovery and interpretation of Cherenkov effect. Owen Chamberlain and Segre, discovery of the antiproton, invention of the bubble chamber. Robert Hofstadter, studies in electron scattering of atomic nuclei, research into the resonant absorption of gamma rays. Mossbauer. Landau, theory of liquid helium. Liquid helium is a superfluid, is kind of the idea. And so if that's Landau, it's got to reflect more on Fritz London, because he just is a super classical account, and he's got mathematics and formalisms that I'll be looking through as I go through more of these thousands of books. I'll be looking for the ones from Fritz London, or to be studying more his original sources. Feynman, Schwinger, and Tomonaga got development of quantum electrodynamics. So Schwinger's kind of given the path integral, and then Tomonaga is also with Schwinger, and then Feynman just kind of made some nice diagrams and popularized it a lot. So when I learned about path integral, it's like, well, Feynman invented path integral. I'm like, okay, great. Then I studied the path integral. It's like, well, yeah, Feynman learned path integral from Schwinger and Tomonaga. It's like, okay, fine, great. And then it's like, well, in quantum electrodynamics, that all these virtual photons just mean nothing because they're supposed to be massless and chargeless, and that's the only thing that kind of works, but they don't really exist. Really, it's a continuum mechanics. It's like, yeah, I get that. I do get that. Discovery of optical methods for studying Hertzian resonance in atoms. So more resonance theory, structural chemistry, resonance theory. Bethe, again, about contributions theory of energy production of stars. So stellar formation and pulsation, and then how that relates to models just like orbitals or models of orbits, kind of about the same thing in the classically as much as could possibly be so, and then about all the different ways that make for the effects of making bonds according to nuclear structure and electron orbitals and chemistry, nuclear chemistry and atomic chemistry and structural chemistry and molecular chemistry. That then the stellar models are so similar as with it's just kind of like a point, and then how does it grow? Zero. Like how many sides did it have and this kind of thing. Vis-a-vis stuff like Chandrasekhar and Schwarzschild, and it's like, well, this is helium and hydrogen, and so according to gravity, it just kind of sits there and spins a bit and fuses. That's the way it is. Gell-Mann, so that and then it became like these are our standard model of physics, is Gell-Mann there. Alvin and Neal, discoveries in magnetohydrodynamics, discoveries in antiferromagnetism and ferromagnetism. These other matters of the medium and energy and configuration, thusly, of the experiments. And then with regards to electrical and magnetic fields and the various things that go on with those, about potentials and some potentials and all this kind of thing. Invention of holography. Now that's a great sort of account because it's like, well, light is like a wave. It's like, yeah, it's like also it travels unimpeded with regards to itself. If it's not coincident entirely, it doesn't constructively or deconstructively interact with itself. It's like, oh yeah, everybody kind of forgets that when they call it electromagnetic radiation. It's like, yeah, they kind of have to forget that, or else they'd be wondering. It's kind of these ideas, discoveries in magnetohydrodynamics, holography, jointly developed theory of superconductivity. So that's given to Bardeen, Cooper, and Schrieffer after 40 or 50 years after the developed theory of superconductivity. So Cooper pairs and stuff like that are often as about Bardeen, but Fritz London is a theorist who very much foresaw what these guys would later write at all. They must surely have been thoroughly influenced by his formalisms. The Iwasaki, Ivor Giever, I'm not sure how to pronounce it, Giaever, Javier, Brian D. Josephson, discovery of tunneling in semiconductors, discovering of tunneling in superconductors, and theory of supercurrent tunneling. So that gets into a lot of these different ideas of scattering and tunneling. So after quantum electrodynamics, it's like, well, what's going on here? It's like everything's scattering. It's like, what's this stuff flowing backwards then? It's like, now it's tunneling. Okay. You know, it's like, well, how does this fluid model work for current? It's like, well, it works great. It's like, so it's just like liquids, and as you apply pressure to it, it comes out and spouts from the middle. It's like, well, yeah, except it does it from the edge, and it kind of sucks in instead. It's kind of reverse everything else. It's kind of like bizarro water, this electricity. But according to these formulas, they're no different at all. It's like, okay, so these are the things. Pulsars, pioneering work in radio astronomy, are Hewish and Ryle. Bohr, Modelson, and Rainwater discovered the connection between collective motion, particle motion, and atomic nuclei. So today we got to distinguish that with like random walks, Brownian motion, the adiabatic and non-adiabatic, and these things. So they found kind of like a formalism. It's like it kind of goes in one direction as long as it's going that way. I mean, not to belittle these accounts at all. It's just like mathematics. Oh, it's physics, how it works. And so it's given to that what it is. Independent discovery of the J over psi particle, Richter and Ting. So is that standard? It's like, I guess not, you know. Theory of magnetic and disordered systems, basic conventions, discoveries in low temperature physics, discovery of the cosmic microwave background radiation, unification of electromagnetic and weak forces. So this is Glasgow Solomon Weinberg after the great account. This is quark physics. And so this unification is like, there are others. So this supersymmetry is like, there are others, and these kinds of accounts. Discovery of the K naught CP violation, charge parity violation. Still no time violation ever. But accounts of supersymmetry being justified again. Contributions to development of laser spectroscopy. Contribution to development of high-resolution electron spectroscopy. That's Blomberg and Shallow and Siegbahn, so that's in applications for sure. Because those are two different things now, and then they need different accounts. And then does light work the same as these electrons? It's like, no, but if you pump it through lasers, it can kind of be made so, according to the configuration and energy of experiment. Theoretical studies in the structure and evolution of stars. Nucleosynthesis of elements inside stars with Subramanian Chandrasekhar and William Fowler in 1983. Carlo Rubbia, Simon Vandermeer, discovery of W and Z particles. They hit the detector. Discovery of quantum Hall effect. Now, the quantum Hall effect is super classical, you know. It's like, what about the quantum Hall effect? Was like, what about half of that? You know, these are the things that kind of are the things. Up to the 80s here. Neutrino beam method, demonstration of two kinds of neutrino. Pioneering research into deep inelastic scattering. That's like making scattering. So it's like, well, does it add up at the edges? It's like, well, if it's deep and inelastic, it does. And then to get some like, you know, 't Hooft developments showing that gauge theories, especially that of electroweak force, are renormalizable. It's kind of like, it's like, well, then you denormalize them to get there. Anyways, that's just kind of an account of physics in a shallow sort of reading of it, but you know, according to what's supposed to be the signpost of the discoveries. Kant's The Critique of Judgment. So Kant has his critique of aesthetics and critique of judgment. So this is kind of the last book to read from Kant, or the first, but it's kind of like what he says is like, well, according to this is like, this is what we can say is so. Let's create a great analytical index to aesthetic judgment, finality, field, faculty, fanaticism, fear, form, freedom. Yeah, now and freedom is matters of change in state. You know, it's lots of different ideas. See concept, the conceptualization of things, to make a sept of something, to make something. The genus, furniture. Compared to other terms like gardening, general, getting into the aesthetic, grotesque, happiness, harmony, health. Homer, contrasted as poet with Newton as scientist. Newton is sort of a panel of a man, while at the same time of great sorts of accounts. I separate his numerical methods to be like, that's Gregory's and Coates's. And I separate his analytical methods like, yeah, thanks McLaurin. And then I separate his physical methods like, Kepler Kepler and Galileo and the Mertonians really gave a lot to that. And then, in fact, quite a lot. And then besides that, for Hooke's law and inverse square, then there's Hooke. So a panel of a man. And then he went on to work for the government or something like that. Idea. Imaginative power. It's a great account that it's like, great ideas can begin, and result acts of information advantage, the idea advantage, because it's kind of like this lever, all I need is a place to stand and a fulcrum and a sufficiently applied force and a sufficiently strong lever, and it can move. It's like, well, I'm glad you thought of that, because otherwise it would just be kind of trying, that kind of account. Intuition, judgment. Middle term between understanding and reason. So I would express that instead as between comprehension and reason, because understanding is an eventual failure. Like metaphor eventually fails. There's a strong metonymy, the true names and words of things, that is complete and consistent. And metaphor, even in an account like this, it's to tend to be intersubjective and attain to that there is a grounds for judgment. Is the same as then for that there's reason. So that reason and comprehension can be the same sort of account, instead of being two different sorts of account. One the working and the other the workings, or that kind of thing. So let's see what he says about judgment. And this then is getting all these relating to this and things. Judgment. Principles of annexed as needful to theoretical practical philosophy, as synonymous for sound understanding, a priori principle of difficulty in understanding, in discovering. Especially great in case of aesthetic judgments, a priori principle of necessary and logical judging of nature, when. No reference to feeling of pleasure and logical judging of nature. Separate division for why necessary and critique. Critique plays part of theory in case of. So this is, in this index, he's relating, usually index will just refer to a page number, where then in the context that the term will be related. But this is relating to these other terms as their fragments themselves. And then also the page number. Law of specification makes us proceed on principle of conformity of nature to our faculty of cognition. And here for those accounts of the inductive impasse and morass and the bogs and the analytical bridges to help to account for that there is a real map and it's a map of the world, then these are ways to help reflect that this principle of conformity of nature can be accommodated, besides the fact that otherwise the invincible ignorance is our own fault. Ignorance is not a defense. And sometimes understanding is presuming too much. But there is something real. Oh, here he says, this is something I might find agreeable. Teleologically employed assigns determinate conditions. So that's kind of the difference between the teleological account and the ontological account. It's like, it's true. It's like, that must be true. Es muss sein. And it's fine, and that's okay. Provides constitutive a priori principle for feeling of pleasure and displeasure, or approval and disapproval. Grounds of clear or confused judgment. The grounds. Mathematically determinate and reflective, contrasted. Of experience, cognitive, contrasted with aesthetic. So the cognitive contrasted with aesthetic can just be matters of reaction and the undefined and underdefined, and what people like, and these kinds of things, or what art is, and the aesthetic and art and these kinds of things. So that's going to vary, but the cognitive is not necessarily needfully contrasted with the aesthetic, because for a theory of science and a scientific theory, there's a very strong conscientious consciousness that what's beautiful is true, and what's true is beautiful, and that kind of thing. And thus everything has its own truth and beauty in it, which is nice. Judgment of taste. To be against the tasteless is the usual idea. Critique of teleological judgment, part 2, division 1, analytic of teleological judgment. Intrinsic natural perfection. So, yeah, Kant in the Sublime is giving us a great account of reason and judgment and for the phenomenological. And it's like, well, yeah, Kant is really rational and he won't be confused by his senses. And furthermore, he won't allow you to say anything except what you can relay in the interrelatable, intersubjective terms. It's like, well, how does he do that? It's like, well, of course, he just refers to these things that are perfect anyways, and so there's nothing that can be said about it otherwise. That's the Sublime is the given account. And then Hegel is given the account as like, it begins, it's nothing, it's everything, here it is. And so whether that's being or nothing or these kinds of account is like, it's an account. And it's there. So, Hegel's given a great account as for Aristotle and Kant is for Plato. Or vice versa. And together. Those then are given as the usual kind of the giants of the lions in a sense. I ought at all times to reflect upon these things according to the principle of the simple mechanism of nature and or paucity or the principle of least surprise, Occam's razor, and these kinds of things. That being then according to this principle. And consequently, push my investigation with it as far as I can, because unless I make it the basis of research, there can be no knowledge of nature in the true sense of the term at all. So here that reflects on the principle of sufficient reason. It's like, that's enough. I get it. It's so, basta. It's done. It's enough. It's done. It's a fate. It's over. It's a work. Compared to, it's like my principle of sufficient thorough reason means also it's not so, and the rest of it as well. So that's why here there's a principle of inversion instead of non-contradiction, and a principle of sufficient and thorough reason, and the fair and the fulfilled and this kind of stuff. Reason remains reflective. Skipping the terms a little bit. It's like if one makes an exercise like, well, what happens if you read the first letter of the column of the words? But what happens if you just kind of read through the terms that have been expressed in italics for emphasis? Let's see here. Critique of judgment. Critique of teleological judgment. Estimates are solely possible in this way. Ought reflect according to the principle human reason. Reflective. Also, on the old saw, that may be right in theory, but it won't work in practice. So the difference between the practical and theoretical is often attributed as a quote to Yogi Berra, who I seem to recall as a baseball player or something like that. He said that might work in practice, but it doesn't work in theory, or there's a difference between theory and practice is practice and theory or something like that. I forget the exact quote. That's a good one that belongs to the person who kind of coined that quote and wherever they heard it from or made it up. But it's because the terms go back and forth so much that there's so many ways to read them around each other that may work. That theory may work in practice, but that practice may work in theory, but that theory doesn't work in practice or something like that. So here, Kant and the Old Saw is just kind of like. This works in Continental Philosophy, General Editor John R. Silber, Silber, from University of Pennsylvania Press. Translated by E.B. Ashton. Introduction by George Miller. In Memoriam of Frederick Wieck, one of the last of the civilized editors, 1974. The editor's forward, few people are so ignorant that they will dispute the value of theory. So obviously he's kind of strongly inclined that there's a great strength in philosophical theory. Kant's essay, addressed to a broad intellectual audience, is one of the most neglected, though most important documents of the Enlightenment. When I think of something like Quine's notes on materialism or something like that, or empiricism, it's like, I mean, he's like, well, not this way and then around this way. And it's like, well, no, Quine, actually just not that way at all. And so what Kant may be saying here is like, it can be read again, it's kind of like, to some adherents it would say something, to some adherents it would say something else. Kant's essay, addressed to a broad intellectual audience, is one of the most neglected, though most important documents of the Enlightenment. Where the Enlightenment is reason and rationality, and then the Renaissance is ideals again. So that's just the considering circulus logicus virtus, ideals as intuition, and reason and rationality as constructivism. But today we have a very, very strong and thorough one, all the sort of account. It is here published in English as a separate volume for the first time. Its relevance today depends least on its contribution to Kantian studies, though in theory and practice, Kant elaborates significantly on the role of happiness in ethics and provides its clearest discussion of moral feelings and the nature of ethical motivation. So that's that's related to kind of like the mental maturity, the emotional maturity, the mental or the moral maturity, the ethical maturity, and whether those are the same. Usually, those are all left out, because here there's just a conscientiousness accorded to reason and logic and truth, and that's enough. It's on its own sake beautiful. It's good. Its importance for today derives primarily from Kant's brilliant discussion of critical political issues that are of intense contemporary interest: the nature of political authority, the right of revolution, freedom of the pen, the authority to make war, and the preservation of peace. Although these issues raised by Hobbes, Locke, and Rousseau were central to political discussion at the founding of our republic, their relevance even now is undiminished. So that's nice, because then it just reflects on here on Locke and after Montesquieu, and then Rousseau. Rousseau is just kind of a dabbler, it seems like, but he makes some great accounts of inspirational accounts but it doesn't take too much position how to get there. And then Hobbes is just like kind of like, I'm an empiricist and we are too, and this kind of thing. On the relation of theory to practice in morality in general. On the relation of theory to practice in constitutional law. On the relation of theory to practice in international law. So he's writing against Garvey, Hobbes, and Mendelssohn. And then, but that's fine, because these philosophers are making points. And a philosopher need not necessarily make a point that they even want to hold, because it's what their reason could arrive at. And that's why they can be held up as intellectual giants or intellectual equals, intellectual authorities, even though then that it's necessary to confiscate one's own sort of account of it and say that's for its own account, vis-a-vis rhetoric more broadly and widely, which may or may not be the same thing. Word and object, we read that quite thoroughly. Here's a Descartes, see which one. This is the Philosophical Works of Descartes, episodes 1 and 2, or volumes 1 and 2, rather. So about 500 pages here, 400 pages here, 350 there, about 850 pages. The passions of the soul. How these passions are excited by things good and evil, which only concern the body, and what pleasurable simulation and pain exists. Talking about usual motivators of the animal, or the carrot and stick, and these kinds of things. The definition of sadness. Sadness is a disagreeable languor, langur. The languorous just means like the doldrums and this kind of stuff, in which consists the discomfort and unrest which the soul receives from evil, or from the defect which the impressions of the brain set before it is pertaining to it. And I'd suggest it's more the second part of that. But that's associated then kind of with the moral compass and this kind of thing that way. There also is an intellectual sadness, which is not passion, which hardly ever fails to be accompanied by it. intellectual sadness. He's talking about the causes of this. So this is after the definition of joy, and then he's talking about the joy and sadness, vis-a-vis joy and pain, joy and sadness. The part of the philosophical works of Renatus Descartes. Infinite in all directions. So here's Freeman Dyson before, as was kind of mentioned before, and it's like infinite in all directions. He's just talking about all his aspects of things he's seen in the space program. Oh, talk about Star Wars, which is a 1980s plan to control lower Earth orbit with satellites and ray guns and stuff like that. The Art of the Infinite, Kaplan and the Kaplans, Robert and Ellen. The Pleasures of Mathematics. Angles, congruence, fractions, ratios, Cartesian coordinates, the plane, fields, radicals, vector addition, the infinite and the unknown. Let's see if this would be a nice way to just close. Yeah, why should this be? Especially as Spinoza was right in saying that the order of the world and the order of the mind are the same. So this is like University per Duns Scotus, which is a little bit before that. So when the universe seems to conclude in a theory of everything, a window will open up in the far wall onto a landscape unguessed at until then. Paradigms busily tidying up their last details just before they shake and shift. Or they invert. Mathematics builds upwards by taking as stones what were structures before, gaining new heights from which to survey the way things are, how staggeringly far has come in 5,000 years. Wherever every answer found, a flurry of new questions arises. The sequence of ratios of what we don't yet know to what at any moment we do, the terms grow to infinity. They grow down from infinity, starting from infinity. Discusses the art of the infinite, Georg Cantor's accounts. So we mentioned Spinoza and Georg Cantor, so we can mention also Duns Scotus and duBois-Reymond and Zeno. I'll look at this a little bit more for some of the historical content and look for references. Well, gentle readers, good day. Good luck. Reading Foundations.